Okay. Innal hamdalillah nahmaduhu wa nasta'inu. Man yahdihillahu fala mudhillalah wa man yudlil fala hadiyalah. Asyhadu an la ilaha illallah wahdahu la syarikalah wa asyhadu anna Muhammadan abduhu wa rasuluh. Amma ba'd. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Amin, Allahumma amin. Syukran Dr. Amir, syukran Dr. Nolia. Wahaya binabi ta'aruf, let's get acquainted. Ana Muhammad Jeffry bin Mat Johar. My name is Muhammad Jeffry bin Mat Johar. Ana muhandis fi Telekom Malaysia. I'm an engineer from Telekom Malaysia. Wallahi ana uhibbu al-lugha al-arabiyyah aktsara min Kubernetes wa Docker. Well, Kubernetes and Docker is cool, but Arabic is much more cooler. Okay, we're gonna start our session today. So today is introduction to Kubernetes and Docker. At-ta'rif ila Kubernetes wa Docker. Okay, what I will be covering today. In the beginning, what do we have before there is a technology called Docker and Kubernetes, and then we jump straight away into Docker and Kubernetes. Okay, where does all of this started? It all started when we have somebody, either you, your boss, or your department, or your client has a piece of code, but they need to run it. In order to run your piece of code, definitely we need some platform which could understand your code. Typically, or should I say previously, the only option we have is we have to buy the server. This is the era where we call the physical server, or the other cool name for this term is bare metal server. Okay. In order to do this, first, what do we need to do? Of course, we need to buy it. We need to acquire the hardware. As a hobbyist, maybe this is as easy as go to Lawyat or IMBI, we buy a computer. But for the enterprise, this the process is much more longer because we have to get approval from the boss, from the finance department. It's very long process. Okay, anyhow, after you get the hardware, it's still a paperweight. It doesn't do anything. What do we need to do? After that is to install the OS. We have a lot of OS. We have Linux, we have Windows, we have BSD and things like that, even Unix. Okay. Previously, to install the OS was not just like click, 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 and it's done. It's very tedious. Sometimes when we want to buy the hardware, we must also consider whether it will support our OS. Meaning we have to do some homework. It's not just like today operating system where you put in the CD or the pen drive, it will work. Previously, it was not like that. It's really hard. Okay, after you install the OS, you install the required services. Let's say you have your source code is a PHP source code. What do we need to run PHP? We need a web server. Typically, this is it could be anything, but typically it's Apache server. Okay, and before there was a package manager, we have to find the source code of the Apache server and we have to compile it. It's really time consuming. And then later on, people started distribute their services in a binary format, which is easier. We can no need to compile. We just install it and hopefully it will works. But from my experience, it will work with the default setting. But when you want to use it with your application, you need to tweak something. Then it's started the problem which you need to tune here and there, and it will take sometimes. Okay, after you get the services up, then you can deploy your intended application. Okay, all of this to bring your application up and running on this physical server, I would say it will take weeks. From number 1 to number 4, it will take weeks. Unless you are very lucky, unless you are very experienced, you can do this probably in days. But from my experience, the first time or the first few times, you will be facing a hard time bringing it up. Okay, after we have the physical server era, we have the technology of virtual machine. Okay, let's see how can virtual machine improve our timeline. Firstly, we need to set up the virtual machine infrastructure. Okay, normally this is done by the IT department, or if you are a hobbyist, you buy a computer, you install the OS, and you install the hypervisor. Okay, what do I mean by hypervisor? Hypervisor is the service that enable you to spawn the virtual machine. This could be anything. In the enterprise, normally, what I see is people either use the VMware technology or the Red Hat technology. For the hobbyists, mostly my friends are using the VirtualBox from Oracle, which is open source, or the KVM. Okay, once this already up and running, so to get our OS, which is previously weeks, we can get it by 30 minutes. Can you imagine that? We cut a lot of time to get our machine up and running from weeks to 30 minutes, which is really awesome. This is an awesome technology. I love it. Okay, and after we bring up the machine with the OS, okay, the great thing about virtual machine is you don't just bring up an empty machine. You can make a template for the virtual machine, and you can use the template and bring up the virtual machine with the desired OS. Okay, if you want Red Hat, it will bring up a Red Hat OS. If you want Ubuntu, it will bring up a Ubuntu OS and things like that. Okay, after that, we still need to manually install the required services. Okay, during this time, people hardly compile the services from the source code anymore. Mostly people will use the package manager. For instance, if you are using Red Hat, you use the yum. Or if you are using Ubuntu, you use the DPKG, which is the Ubuntu package manager. It's really easy. So, okay, the best thing about this package manager, you don't need to worry about the dependency library and things like that. It's just a one-liner and your service will be up and running. And then you can deploy your application. Okay, so for this type of setups, we can get it this. If you are experienced enough, this could be done in one day. 30 minutes, you get your virtual machine, and then you yum install your Apache server for a PHP application, for example, and then you deploy your application. From weeks, 4 weeks to days. Awesome. Okay, now we're going to see what is the current technology that we have, which is Docker. What is Docker? Okay, Docker is actually is a type like we have a toothpaste, we have Colgate. Okay, Docker is like that. It's a brand. What is the technology? The technology is containerization, which is basically you package your application into a standard format. Let's say similar like ISO, and then you deploy the ISO. Okay, what's the beauty of this? Let's see. Okay, the Docker technology. First, setup, you need to set up the Docker infrastructure. Just like the virtual machine, there is a one-time setup you have to set up. But for now, you have to set up the infrastructure. In this infrastructure, you don't need the hypervisor. What you need now is Docker service. Okay, this can be done by your IT department, or you can do it yourself, because you see, this is a really simple setup. It's a machine. It could be a physical server, it could be a virtual machine. The host OS, if you are it could be anything which is supported by Docker. Okay, currently I can say all modern operating system is supported by Docker. Name it Windows, name it Mac OS, definitely our beloved operating system Linux. Okay, and after you have set up the infrastructure, you can deploy your application, but your application must be containerized. Okay, that is the prerequisite. Okay, let's see how fast we can do this. Minutes. Actually, less than 1 minute. I want to put like second, but it depends on the size of the application. Most of the application I seen, it's within minutes. Okay, it's really awesome. From let's go back to the physical server, weeks, and then we have virtual machine, days, and we have our Docker technology within minutes. Why is it within minutes? Because if you see in the picture, in a Dockerized environment, we don't need any service. Let's say I'm running a PHP application. I don't need to worry about my Apache. When I package it as PHP application, the rest of the requirement will be taken care of by the Docker image. Okay, inshallah, later we will do a quick demo and you will see. Okay, let's see the comparison between VM and Docker. It's quite similar, but there's a lot of differences. Okay, let's see. First,
Mr. Jeffrey, sorry for interrupt.
Yes.
Does it mean Docker is it's more advanced than virtual machine? I mean, for virtual machine, we can have host operating system and guest operating system.
Correct.
While in containerization, we just need one host operating system and it will be shared among the application.
Correct.
Okay, this is
I couldn't say that Docker is more advanced than virtual machine, because virtual machine have its own, between these two technologies, there are pros and cons. But both are currently the standard practice in the industry. Both are
Okay.
heavily used in industry.
Alright.
Okay, let's see the comparison. What is the difference between VM and Docker? Firstly, if you see in the pictures, if you want to deploy an application on virtual machine, you have to spin a operating system for that application. Meaning, if okay, let's say you want to execute a 1 megabyte of PHP application, but you need to spin 1 GB of resources for that application because you need to deploy the operating system. Operating system is quite big. It takes a lot of resources from the host OS. Compared to Docker, you don't need an operating system. All it required is you Dockerize the application. All of the operating system, libraries, and kernel will be shared by Docker and the host OS. Meaning there's only one OS in the Docker environment, but in virtual machine, for every application, it will spawn a new OS, which is a high footprint for deploying a small application. Okay. Another big difference between VM and Docker is, as you know, if you want to restart an operating system, it will take at least a few minutes. But for a Docker container, you can start it up by seconds. It's really fast. And apps in VM, it either be in binary or script format, meaning you have to compile it, or if your programming languages is script based like Python or Perl, it will work with the interpreter. But in Docker environment, your application, you must package it in a Docker image format. Okay, that's the difference. And in VM, okay, once you spin a VM, people have the tendency to run a lot of application in that VM. Why? Because okay, we cannot like have one application in one operating system. That is really waste of resources. So what normally people do? People tends to put a lot of application like PHP, Apache in the same server. But in the Docker container environment, in a one Docker container, people typically put one application. Okay. Okay, now comes to the security comparison. Okay, let's say a container is compromised. So only one application will be affected because it doesn't share the platform where it execute the binary. But for a physical server, if the physical server is attacked or compromised, the whole application in the virtual machine will get affected. But if you notice, there's one caveat here. Docker container share same kernel with the host OS, meaning an attacker, if there's a vulnerability on the host OS kernel, they can manipulate that vulnerability and get to the host OS kernel. what will happen when they do this? The whole environment is compromised, meaning it can get to the host OS, which is theoretically this is really dangerous. The whole the whole the whole environment could be down. But to mitigate this issue, we can control our Dockerized application. And there's a few security measures, like you don't allow your user to run as root. For example, we can do that and things like that. For the security issue, we can check it out from the Google website. What is the best practice to run your Dockerized application? Okay, so now how do we scale this Docker? Okay, let's say we have uh, a Docker environment, but the all of the resources is fully utilized. Let's say this two app is very heavy, it fully utilize the host OS resources. What can we do? First, we can do vertical scaling. What does it mean by vertical scaling? We add CPU, RAM, or disk to the host OS. But this is limited by the hardware. Some hardware, for example, only allow you to put so much RAM on the server. Okay, that is the limitation of this vertical scaling. Okay, what do we have next? If all of this is being used up, so we can do horizontal scaling. Instead of we pump in more CPU and RAM to the host OS, we can build another Docker environment and we can load balance. But how do we do this? We copy this box into another box. Okay, this is actually is not a wise move. One thing is it's really tedious when you have a copy of environment into another environment. Firstly is the operation will be double up, meaning you have to maintain two environment. And let's say I want to upgrade app 1. I have to upgrade at this server and I have to upgrade at another server, which is doable but tedious. But previously, people do like this for the horizontal scaling. But then there's another technology which is known as Kubernetes. Okay, what is Kubernetes? Kubernetes, if you Google it out, they use the terminology of orchestration of your Docker environment, which is correct. But I would like to simplify that definition. I would say Kubernetes is something to manage your containerized application. On a Kubernetes, the developer, the 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 user who wants to deploy their application can focus on coding only, because on Kubernetes you don't really need to worry about the infrastructure anymore. That's the main idea of Kubernetes. Okay, what do we get with Kubernetes? Okay, you don't just get platform, but your platform gonna be gonna be high available. It will have multiple nodes that will build up your platform. Secondly, your application will be auto self-heal. Okay, without Kubernetes, you have to do some scripting, like if this application went down, please bring it up. or you can use the monit service from on a Linux. There's a service called monit which will monitor your application. If it's down, it will bring up. Okay. On the Kubernetes, you don't need to do all of that scripting. It's available by default, auto self-heal. Meaning, if you deploy on Kubernetes, your application will be up and running. If it's down, Kubernetes will bring it up. And it will have load balancing if you deploy multiple applications. And all this comes by default. All you need to do is to configure it. Okay, 3 requirements to be in Kubernetes. You have to do a one-time setup of Kubernetes cluster, and we will see how a Kubernetes cluster on the next slide. And the application must be Dockerized. Okay, this is where the similarities of Kubernetes and Docker. Just now, in the Docker Docker environment, you deploy your application on a server which is running a Docker service. But on Kubernetes, you don't do that. You deploy your application on a virtual place where you don't know which server your application going to reside, but it's run happily and very, very stable. Okay, thirdly, you need a person who knows how to use the commands of Kubernetes, because the commands is quite challenging at first. The learning skill, the learning curve to know the commands is quite challenging, but it's doable because we have cheat sheet and everything. You need to know the technical know-how. Okay, this is how Kubernetes cluster looks like. This is a very simplified diagram. What do we have? We have a master node and a worker node. Okay, what's the task of a master node? It's basically a management of the server. And what it will manage all of the internals requirement of Kubernetes. And then we have the worker nodes. For the worker nodes is where your application going to be reside. The developer don't see all this. What the developer need to know is how to use the Kubernetes command line and where should it submit the configuration file. Okay, on the Kubernetes, developer don't need to install anything except they must have the client to connect to the Kubernetes cluster. Okay, inshallah I will do a quick demo. Before that, any question before I switch to my terminal? Okay, sure. Okay, let me switch my screen to my laptop. My laptop is running on a Fedora 31. It's a really cool OS. Dr. Amir, do you see my screen? My terminal? Okay. Okay, thank you. Okay, first, let's say I have a PHP application and I want to deploy this on a Docker environment. Okay, first I need to install Docker. To install Docker, you have to go to the Docker website, and because it varies what type of operating system you use, it depends on that. For me, I'm using Fedora, and I had issues initially because Fedora is really advanced. It's more advanced than Docker, until Docker cannot execute on Fedora, because Fedora, there's a few libraries is too advanced for Docker. So I have to uh, install a older library to make Docker works. Anyhow, uh, please go to the Docker website to see how to install Docker. Okay. Firstly, I need to start up my Docker. Okay, Docker already started. So I'm going to go to my workspace, Docker, my PHP. Okay, let's say I have a PHP application and I want to run on this Docker. Okay, first I have to code my source code first. Okay, it's a really simple application. Okay, if I'm running on a virtual machine or physical machine, now I have to install Apache, and now I have to install PHP. But on a Docker environment, I don't need to do that. If my intention is to run a PHP application, I would go to the Docker website. Okay, I want to run a PHP application. I go see, check out for PHP. So here it goes, PHP. Okay, we go to tags to see what version do you need. There's a lot of version here. Want to check what do I use in my source code. Okay, let's say I want to use PHP 7.2. PHP 7.2. Okay, there's a lot of images here. There's a FPM. FPM is the fast performance Apache, but we want to use the normal PHP with yes. Let's say I want to use this version. So what do I need to do is to pull it down. Okay, this is the base image. As I said earlier, for the application that need to be executed on Docker, you have to Dockerize it. How to Dockerize it? you take your source code and put in this Docker image. Okay, this is the process, and then what you need to do is you have to create a Docker file. Let's see how a Docker file looks like. Okay, it will take whatever the images that you have downloaded, and then you copy your source code into that image. Okay, this is what the Docker file will do. And to build this is you run this command, docker build -t tag. We're going to tag, so my php, and then you can give it a version. Okay, it already create your, this is your customized PHP application with your source code. So how do you check this out? Yes, grab my PHP. Okay, see, this is the one that we just did, my PHP version 1. Okay, why does it says it was created 2 months ago? Okay, Docker is really smart. If it's see there's no changes in your source code, it won't create new images. It will just reuse whatever the images that you have. Okay, let me try to 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 add something. Okay, now I'm going to recreate. Now I'm going to give it a version 2. There you go. That my PHP version 2. Okay, this is our newly created Dockerized image. Now, how we going to use this in our server or in our laptop? Just now we have built it. Now we want to run it. To run it, docker run -p. It will auto assign ports to your application name and the version. Okay, let me open another terminal and see. This is my application up and running. Docker ps to see what application is currently running on this system. Okay, you see, my application is exposing port 8080, but it's SNet to this port on my laptop. So in order to access this application, I have to use this port. Okay, I'm going to open my browser now. That's what port is it? tada, my PHP application is up and running without installing Apache, without installing PHP. And this application will work on any servers which has Docker installed on it. Okay, what's the best thing about this? It's really portable, meaning if you code your application on your laptop, if you deploy it on the server, 99.99% it will work. On a VM, let's say you code your application on your laptop, when you deploy on a server, sometimes it doesn't work. Why? Because probably libraries or version of your PHP or whatever, your Python or the interpreter is different from the server. But for the Docker environment, it will stay the same. If you notice why this is like that, because when we download the base image, it already specify the version. Like me, I'm using the PHP 7.2. So my application will run on PHP 7.2 anywhere. This is already hard coded in the image. Okay, that's the beauty of Docker. And one more thing is, do you notice it's really fast? To bring it up, okay, let's see. We do it one more time. Oh, sorry. Okay, just now I was running the interactive mode, but now I want to make it as a daemon. -D. So it will run in the background in this machine. Okay, if you see here, it's really 2.356 seconds to bring up this application, which is very fast, less than 1 minute. If this is on VM, you have to start up the Apache server, and if you want to include the OS boot up, that would take several minutes. But in Docker, this is really fast. Okay, that's Docker. The next demo I want to show is Kubernetes. But for this demo, I need to log in into my office. Okay. Typically, the practice of the industry today, if you want to get into your office environment, you have to log in through VPN. And then after you log into VPN, then you can use whatever technology you have in your office. Okay. Before that, any question?
So Jeffrey, we have 3 questions here.
Okay.
The first comes from Megat Haikal. Sorry. The question is, do the container of Docker has access to the kernel?
Yes. As I told in one of my slides, it shared the kernel. That is where we have to take note when, let's say there's a bug in the kernel, we need to patch it quickly because it's really dangerous.
Right. The second question comes from Muhammad Irshad. The question is, this Kubernetes and Docker technology is suitable for what kind of services?
Okay, I would say for all type of services, but it was meant for microservices.
Microservices,
If you want
okay.
to uh, the if you want to use this for monolithic type of services, you have to do some sort of tuning. For example, let's say your application needs like a very big resources. For example, 32 GB of RAM. But your host OS for the Docker only have 16 GB. That won't work. And for microservices, normally we don't have that kind of application. Most of the application is really small, but they can deploy into multiple Docker container.
Right. Okay. The second question is, what if the application is bigger in scope? Can Kubernetes and Docker solve it?
Sorry, again?
What if the application is bigger in scope that can Kubernetes and Docker solve it?
Okay. That is a very good question. Recently, I have this request from a team at my office. They need a really big computing power for data crunching. They need if I'm not mistaken, they required 128 gigabyte of RAM and a GPU computing power. Okay, for this type of application, uh, it is not suitable for Docker, even for virtual machine, because virtual machine, okay, you can set it up on whatever size you want, but normally in enterprise we already have a fixed size, like a t-shirt size, L, small, or extra large. Okay, normally we don't go beyond 64 GB RAM for a virtual machine. Okay, for this type of request, normally we suggest the team to buy a physical server, because this is more uh, easy to set up, because we don't messed up with the current working of the virtual machine, and uh, and and it is best to be like that, because for a super when you need a super powered computing power, the only thing that is currently uh, easy to set up is a physical server. Meaning we still need the physical server in today's environment. There's a there's a there's still a needs for that.
So in terms of efficiency, which one is better?
Efficiency compared.
Between Kubernetes and Docker, which one is better in terms of efficiency?
Okay, efficiency, definitely I would say Docker, because one, the developer don't need to know about the operating system at all. What do they need to know? All they need to know is how to containerize the app, and where should they put their application. For the Docker environment, you still need a one-time setup of the Docker host, and then you need to install the Docker services, and then you can run your Dockerized application. But for the Kubernetes, we don't need to do that. We just deploy our application on the Kubernetes cluster. But the one-time setup of Kubernetes is another different story lah. That one is quite tedious, but once once the cluster is up and running, it's really easy to use.
Okay, all right. This is the last question for this session. We will have more questions after this, Mr. Jeffrey. So the last question is, can we use it without?
Sorry, the question?
Can we use Docker or Kubernetes without download Apache?
Okay. Actually, the main idea of Docker is you don't need to download any other services beside Docker service. Like what I showed just now, I don't install Apache, I don't install PHP. What I need to do is I need to find the images from the Docker website.
So do you mean the container images?
Yes,
Okay.
it's all in here. Okay, let's say
Mhm.
I want MySQL. I just take this MySQL image and use it. I don't need, basically, I don't install MySQL on my laptop. I just use this image. Okay, this concept is pretty much similar like, okay, if you ever use um, okay, some of the pirated software, for example, like Photoshop, is distributed in a zip format. Where you unzip, you use it. Okay, this concept is pretty much similar to Docker. It's zip in some format. You just use that. You don't even need to install. For example, the Photoshop, if you buy from Adobe, you have to install it. You have to click the setup and it will install. But the pirated one, you just unzip and use it. But anyhow, I don't use that kind of software because I'm using Fedora.
All right. I think Ms. Jeffrey, you can continue with the Kubernetes demo. We will
Okay.
continue next question after the demo. Thank you, Mr.
Okay.
Jeffrey.
Okay. Now I will go into my office. Okay. For security purposes, I don't show the password and the links to my office. I already create a script to log into my office. My VPN. This will connect to my office. Okay. Let me log into my Kubernetes cluster. Dr. May, I couldn't share my screen. Right, thank you. Okay. On a Kubernetes, firstly, you have to containerize your app. Okay, once you already containerize your app, you have to put it somewhere. In for your own private laptop or your own private setup, you can host it at the Docker website just now. But for the enterprise setup, normally we don't allow that. For security purposes, we host the images at our own office, meaning we put it in a repo server where we hosted all the images. Okay, this for the repo server, we use application named Harbor. This is an open source project. Yeah, this one. You can install it and use it at your office or at your private site. So by using this, when you already created your Docker images, you upload to this server. Okay. Once your images already uploaded in the server, you have to create a manifest file to deploy on Kubernetes, because on a Docker just now, we just issue a command, Docker run your image, it will run. But for Kubernetes, you need to make a manifest file in order to deploy your application. Yes, this at first it's really look very weird, or it's look like a spaghetti incident, but actually it's really easy. The first thing that is super important is the name. What you want your name to be known, what you want your application to be known to this Kubernetes. Okay, for me, I just put my PHP. And then what port do I want to expose my PHP? It's port 80. Okay, this is the service layer. And then we go back, we go down to the deployment layer. We maintain the name, should be the same. And from where we're going to get our image. See, I already uploaded my image to this Harbor. And I'm going to use this image at version 2. Okay, I already uploaded this image at this Harbor, so I can use it now. Okay, how to use it? As I told earlier, the required number T is you need to know how to use the command. Okay, at first this command is really really weird and really alien, even to me. But after I've been doing it for so many times, it's come natural. But it's okay. All of these commands is available from the official documents and official website, and even they provide a cheat sheet for these commands. Okay, to deploy this application, simply like this, kubectl apply -f the application. So it will deploy the service and the deployment. Okay, how to check? Kubectl get on. Okay, see, this is my application. It's up and running, very fast and uh, very fast and very stable. What do I mean by stable? This application, if it go down, it will be auto rejected by Kubernetes. Okay, how I want to show this as a demo? Let me check. Okay, okay, this is the application running, but now how I want to expose this to the outside world. Let me check. I have. Okay, cool. Okay, we have our application running in the cluster, but this cluster is separated with the intranet. So how I want to expose this outside? I need something as a bridge that will bridge my application to the external network. For this, in the Kubernetes world, we call it ingress. Okay, now I'm going to deploy the ingress. Okay, thank you. Okay, let me check if this is up or running or not. Pod. Okay, it's not secure because I don't install the SSL cert. It's fine. We can. Okay, for some reason I couldn't expose it outside. It's okay, but it's working. I can use my command line web browser, which is curl, to get to my application. Okay, now I want to show a demo. How can I, let's say, I kill this application? What will happen? Okay, clear. Get hot. Okay, that's the application. delete this application. If you notice, I delete, it automatically bring up another application. See, it's already a different name, meaning it already spawn another application to replace the deleted one. This is what we call auto self-heal. And how about if I want to scale this out? Meaning, let's say this is a La Pasa website which is running e-commerce, and Hari Raya is coming. A lot of people is buying baju Melayu and things like that. Okay, maybe traditionally, if I have one web server, I will create another web server and then I load balance. Okay, how can I do that in Kubernetes world? It's really easy. Okay, now if you see, let's go back to our okay, we have replica one, meaning one application. So let's say I need 3. See what happens. Almost instantaneously, I have 3 application and it's auto load balance. Okay. Without I need to install another operating system, without I need to buy a load balancer, it works out of the box. Let's check it out. We use our curl. Okay, we check it out. It's accessible. Check out the host name. This one is this one. It goes here. J7. This web server. The second time it goes to another web server, but it will. But I will get to my application. Only it's on a different web server. It's load balanced automatically by Kubernetes. Okay. I guess that's all about the Kubernetes demo. And before that, okay. I know to set up Kubernetes is really a long process, but how can we learn all this technology without installing all this? Luckily, there's a website. They have Kubernetes and Docker for us to use without the needs to install Docker or Kubernetes in our laptop or in our server. Okay, let me quickly share the link. Okay, this website is really awesome. It gives you a test environment which you can build or play around with Docker and container. How can I share this link, Dr. Amin? Okay. Okay. All right. In the comments. Okay. Okay, that's all for me, Dr. Ami and Dr. Nolia.
Right. Thank you very much, Mr. Jeffrey, for your interesting and very informative talk. All right, ladies and gentlemen, now we come to the question and answer session. So I would like to open to the floor for your question, and I'm sure Mr. Jeffrey will please to answer them. Okay, Mr. Jeffrey, we have a question from Haziq Sulaiman. What is the advantage of a virtual machine compared to Docker?
Okay, one of the advantages from this security perspective is virtual machine. All of the virtual machine is using their own operating system. Meaning, if the kernel is attacked, it won't involve with other virtual machine. But in Docker, when let when when there's a bug in the kernel, the whole environment could be affected. And secondly, uh, advantages of virtual machine is you can install whatever application that you want that available to you. Compared to the Docker, you are bound to the Docker images from the Docker website. Okay, there's a workaround to it, because if you cannot find a Dockerized application at the Docker website, you can create your own Docker images. Because if you see, the most basic Docker image is operating system. So from the operating system image, you can build your own application. A long way, but it's doable.
Okay, right. All right. The second question come from Parvis. Is it possible to build iOS application without Mac using Docker?
Sorry, again, the question?
Is it possible to build iOS application without Mac using Docker?
iOS application.
Without Mac using Docker.
Okay. I guess the question is referring to mobile app development.
Yeah.
I would say no, because currently, if you want to build a Mac or iPhone app, you need a Mac OS.
Okay. Right. The question is, what is the difference between deploying application on host and container?
Okay. Deploying on host. Okay, let's say you want to deploy a Python application. You need to install Python first, and then you can deploy your application. For PHP, you need to install Apache first, and then you install PHP. Then you can deploy your application. Okay, that is on VM. But on Docker, you don't need to install anything except you go to the Docker website, get your intended application images, and you put your source code in that image, and you deploy it on a Docker container. The okay the main difference is, for a VM or physical server, you need to install a lot of things, libraries, PHP, Python, and things like that. But on the Docker container, you just need to get the image. Once you get the image, you put your source code in the image, deploy it on the Docker. and it will run anywhere that have Docker. Okay, this is good, one thing. Okay, this always happened to me when I was a student. Maybe I'm not so lucky. I do my homework on my laptop, it works fine. But on the day I want to show to my lecturer, I put it in somebody else or the lecturer laptop, it doesn't work. Why? Because my laptop have different version of, for example, different version of Python. Python, for example, 2.7. The lecturer have Python 2.73. For some reason, on a very unlucky day, that minor version causes my homework doesn't run. So if you are using Docker, we can avoid that because why? Once we are already created the image will run, execute your application on that particular version anywhere. So 2.7 here, 2.7 at the lecturer laptop.
Right, so it's very interesting. Okay, okay. The next question, Mr. Jeffrey, can Kubernetes run without Docker?
Yes. Okay, but that is the standard. The Kubernetes, okay, as I said just now, Docker is actually a brand. The technology is container. There's a lot of container so-called brand out there. For example, Podman, Rocket, and things like that. Yes, you can run Kubernetes with those type of container, but it has to be a container technology. That is required by Kubernetes because Kubernetes task is to orchestrate the container technology.
Okay, right. Another question is, what is the difference between Kubernetes versus Openshift?
Okay. Openshift is okay. Kubernetes. Okay, I can say like this. Kubernetes is to manage Docker container application. But who's going to manage Kubernetes? Okay, we can do it manually, meaning we have a lot of servers. We install Kubernetes on all of these servers. That is manual task, which is not a very practical practice in enterprise environment because that is really tedious. Okay, Red Hat come out with Openshift. So this Openshift will create the Kubernetes cluster from a resource pool. So it's meant to be to manage the Kubernetes cluster, meaning Kubernetes manage Docker, this Openshift manage Kubernetes. Okay. That is one product. There's a lot of products similar to Openshift. Okay, for the rival for Openshift is VMware. VMware has a product called PKS, which is similar to Openshift.
Okay. All right. This is another new question. What will happen to the Docker if the Kubernetes were not applied to it? I think you have answered before.
Okay. I think I like to answer that question this way. Kubernetes does not require Docker, meaning Kubernetes can manage other type of container technology like Rocket or Podman. And Docker don't need Kubernetes to manage it. There's other technology could orchestrate Docker. For example, Docker itself has a manager called Docker Swarm, meaning it can orchestrate Docker container, but it is not. I couldn't say like it's not famous because a lot of people using it, but Kubernetes is a lot more enterprise using Kubernetes instead of that other technologies. I can say like that. I think I safe to say like that.
All right. Is it the Docker doesn't? Okay, is it Docker is very efficiency that it doesn't need to be downloaded and also faster?
Yes. For Docker images, you only have to download once. For the subsequent creation of your images, it will just use whatever the image already being downloaded to your laptop. Meaning, if you see like the first time you download for a few minutes, because that download time is depending on your network. Okay, that is the first time. For the second and the third time, it won't download anything from the internet anymore. Yeah, it just use whatever you have download in your laptop or in your server.
Okay. So, how far do Docker containers scale?
Okay. I think that question may be referring to the 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 job.
Scalability.
Okay. I can say Kubernetes and Docker is really sought out by the enterprise. Meaning, if you have this skill, I can say you guys are hot stuff. Meaning, easy to get. Inshallah, easy to get job because the trending for Kubernetes is climbing in the industry now.
Okay. All right. So this is the same question from sorry, Mr. Jeffrey. Is microservices are more demanding than big scope application today?
It depends on which industry, but currently microservices is really hot because the time to deploy microservices is really fast, and that is what the business demands for today. For example, that okay, we look at the Grab application. It has Grab Food, the taxi, and some other application. Okay, let's say it's not microservices. When the Grab application want to update the taxi part, the car, it has to bring down all other application. But if it's using microservices, it can only touch that part, the Grab car, on the put it on the maintenance mode. The other application still can be used by the user. That is really cool, and the business like it that way because it does not disrupt things that not to be that's not okay. Let's say you want to update only one portion, only that portion is affected, meaning the rest of the the application is still usable by the user.
Is it making things easier for hackers as all configurations are stored in the Docker file and compose.yml?
Okay. That one, actually once you already deploy your application, actually the user or the hackers wouldn't know whether it's running on Docker or virtual machine because it's transparent.
Okay.
The Docker file and the YAML file is not exposed to the user.
Yes. Mm-hmm.
Okay.
Yeah, okay. All right. Okay, another two more question. Okay, this is come from, do you have a resource which later I can refer to later on? I think this has been shared by Mr. Jeffrey.
Yeah.
Okay. Okay. How about if the application, there is an upload features that needs some file to be saved at the server? How can Docker handle this?
Okay, that is a really good question. For Docker and Kubernetes, the storage is, we call it epiphany, meaning whenever we restart the application, all of the information in that Docker environment will be flushed out. Because for every restart of Docker or application on Kubernetes, we treat it as a new server. Okay, that is good in terms of security perspective, but it gives trouble to this requirement which people needs to put something static or something persistent on a Docker container. Okay. For this issue, Docker and Kubernetes has an option to mount a persistent storage. So in order to keep a stateful volume on a Docker container, we can use persistent storage or volume. This is available for Docker and Kubernetes.
Okay. All right. I think this is discussion will wrap up what Mr. Jeffrey has been shared with us. What kind of specific topic or application will be hot under Kubernetes and Docker in the near future?
I would say microservices because Kubernetes and Docker are meant for microservices.
Okay. All right. So we will like to say thanks again to Mr. Jeffrey for the insightful and very informative talk. Okay. For the audience, thank you for your active participation. So we hope that this seminar will be beneficial to everybody. Assalamualaikum warahmatullahi wabarakatuh and good afternoon.
Okay, thank you Dr. Amir, thank you Dr. Nolia. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you.